Hello once again. Today we are going to finish off A4 and begin B4. So let's get started by reviewing what a test cross is. Cross between an individual with a dominant phenotype and an individual with a recessive phenotype. To see if the individual with the dominant phenotype is homozygous or heterozygous. So you're always going to have a dominant phenotype and you're going to cross it with a recessive phenotype. Then you're going to look at the offspring to try to figure out what the second allele is for the dominant phenotype. Is it going to be homozygous dominant or heterozygous? And you tell by looking at the offspring. So a test cross is going to be used to determine the genotype of the unknown dominant individual. So you're going to use a homozygous recessive individual as a test. So the test cross is to distinguish whether the second allele is a dominant allele or a recessive allele. And now we're going to finish A4, and then we're going to go and start B4. So we did monohybrids last time, and this time we're going to continue on with dihybrids. Before we do that, let's go and review what a test cross is. A test cross is a cross between an individual with a dominant phenotype and an individual with a recessive phenotype to see if the individual with the dominant phenotype is homozygous or heterozygous. So you're going to cross the dominant phenotype with the recessive phenotype. So the test cross is to figure out, in this case they're using P's, letter P, what is the second allele. So it's used to distinguish homozygous dominant from heterozygous. So someone with a dominant, different color here, dominant phenotype with a recessive phenotype, and if they have no offspring that are white, probably going to be this one, homozygous dominant. And if they have any offspring that have the recessive trait, then without a doubt, without a question, that purple is heterozygous. And before we get started on the dihybrids, I want to go through something that I saw on Khan Academy, and it might help you figure out what a gene is and the difference between an allele and a gene. Okay, so here, you should recognize this. Remember that from test 2. A complementary base pair, so this is the DNA. We have A's with T's, T's with A's, C's with G's, T's with A's, C's with A's, G's with C's. And if you recall, it is actually the order of those base pairings that is really important. So the order is important. And this right here, we'll say that that is this little dot right here. Okay? All those different base pairs are right there. So those base pairs are giving us the information, the genetic information that we need. And so if this is my DNA, or your DNA. Now our DNA is double strand, but we're just going to make it like a squiggly line here. And some other colors. So the 3% that we knew as genes, well, that code for protein. So that's what we're going to do right now. We're going to make these different sections here. They're going to be coding for different sections or different proteins. So these are going to be different genes. There's our DNA. Let's just look at, we have 2 different genes. And then right there is part of that one. So we're going to have this gene right here. So these are both going to be coding for protein. So DNA that codes for protein is called a gene. So genes is a part of DNA that codes for proteins. And if we recall how they do that, here's our DNA. Remember, DNA is going to go to messenger RNA, transcription. Then these are going to go out to the cytoplasm using the transfer RNAs. Go to the ribosomes. Ribosomes. Yeah, I can't see that one very well. Color. So this is where all that earlier stuff that we learned comes in, ribosomes. And that's where we're going to be making the proteins. And the PTN is how we abbreviate protein. So all that are genes. So DNA to messenger RNA. Messenger RNA goes to the cytoplasm. Next up, the small part of the ribosome. Transfer RNAs come in, bringing amino acids. And then we have codons. On the messenger RNA, 3 codons code for 1 amino acid, and they're going to be making the proteins. And it's the order of this DNA, order of these base pairs in the DNA, that determines the order of the amino acids, which determines which protein is going to be made. So if this was my DNA, and this was your DNA, and let's look at the green gene. So let's say this is the green gene on mine, and this is the green gene on yours. So as humans, our DNA is pretty much the same, but let's say right at this spot right here, I have a guanine, and the exact same location on the homologous chromosome, you have an adenine. But they're both coding for the same traits. So they're both coding for proteins that do the same thing. For example, eye color. Right? My eye color is blue. There might be something in there that makes mine blue, and since you have a different protein there, being made right there, you'll have a different color. Eye color is actually more complex than that, but just for your example. So we each have 2 copies, but there's going to be a little variation. And those are the alleles. And those are the alleles. They're the same gene because they're coding for the same thing, in this case, eye color, but they're different forms. One is coding for blue, one is coding for brown. So those are different alleles for the same gene. So blue, brown, both of these are coding for the same thing. As we said here, they're both coding for the same thing, with different variations with it. Right, that has a G, guanine, and that has adenine. So the variations of this particular gene are called alleles. Why are they called the same gene? because they're coding for the same thing. In this case, the eye color. So let's get into our dihybrid inheritance. And this is going to deal with two different kinds of traits. And looking at those two laws again. Law of segregation and law of independent assortment. The law of segregation, if you remember, that each gene has two different alleles. One allele is going to go to one gamete, and the other allele is going to go to the other gamete. So the offspring only get one allele from each parent. Then the law of independent assortment. Genes for the different traits are going to be inherited independently from each other. So let's look at the problems. We're going to do dihybrid problems, and there's two ways we're going to do them. There's one way we're going to do the Punnett square method, and then we're also going to be doing the branch diagram, also known as the tree method. In that case, we're going to be using the product rule. Right? The product rule. Probability of two independent events occurring together is the product. It means we're going to multiply of each of their individual probabilities. Here are some examples. If we want to know the probability that if a family has two children, both will be girls. Let's take a look at that. So our next example is when a fair die is thrown, what is the probability of getting a 1 or a 4? If you remember from lab, or equals add. So the probability of getting a 1, first one is 1 out of 6. Right, there's 6 possibilities. Or possibly getting a 4, which is also 1 out of 6. Because it says or, we are going to add them. Don't multiply. So what are we going to get? 1 plus 1 is 2. 2/6, which equals 1/3.